Welcome to this episode of Eureka, and we are going to have a very wonderful conversation about lots of interesting things. Do you know Ganges as a very unique dolphin which does not have almost any eyes? I mean, it cannot see in the mucky waters of Ganges, but it has a beautiful echolocation system whereby it can just send sound, and by the reflection it can find its prey and then hit upon it. We are going to have a very interesting conversation with Dr. Rana, who is currently the chair of Agro Biodiversity Committee of the National Biodiversity Authority of India. Before we start this conversation, let's take a quick look at his brief profile. Keep watching Eureka. It's going to be a very interesting show.
Biodiversity plays a vital role in maintaining stable ecosystem. And this is the fact that India is one of the countries which is rich in its biodiversity. But due to global warming and climate change, our biodiversity is declining rapidly. To conserve the biodiversity, India is a signatory of many international conventions. And there are many scientists who are playing a significant role in its implementation. And Dr. Rana is one of them who is widely known for his contributions in this area, both in India and abroad. Dr. Rana is presently actively associated with National Biodiversity Authority, serving 2 terms as its member, and was Professor of Eminence in Genetics and Cytogenetics and the Director of National Bureau of Plant Genetic Resources at New Delhi from 1989 to 1995. Among this, he has served as a member of Compliance Committee for CBD's Biosafety Protocol, representing Asia and Pacific region for 6 years. He also worked as a member of Convention on Biological Diversity Working Group on Technology Transfer. Dr. R.S. Rana obtained his BSc Honours degree in Agriculture in 1956 from the University of Delhi, studying in the Central College of Agriculture, then part of the Indian Agricultural Research Institute. He later joined the IARI Postgraduate School and obtained his PhD degree in Genetics and Cytogenetics in 1963. He is well known for implementing the Indo-US and Indo-UK project on plant genetic resources with a grant of over $30 million, and he effectively utilized in developing the new campus of the Bureau, equipping its laboratories, creating environment-controlled greenhouses, transfer of state-of-the-art technologies, strengthening the Bureau's regional stations and National Plant Genetic Resources System, and equally important in providing training of over 100 scientists and technicians in leading US institutions. A Fellow of the National Academy of Sciences, India, Dr. Rana was elected President of the Indian Society of Genetics and Plant Breeding and also of the Indian Society of Plant Genetic Resources. He has received numerous recognitions, including the British Council Award for Exchange of Young Scientists, ICAR Award of the National Fellow and the Professor of Eminence, and Dr. H.P. Singh Memorial Award.
Thank you, sir, for being with us. It's a very wonderful opportunity. Let me start with this question, which is related to one of your past work, something like about, let's say about 20 years ago, 25 years ago, when you set up the unique gene bank in India. First of all, let me start with the simple question. Gene bank. Generally, we know bank, where you go, you put your money, and then whenever you want, you can withdraw it. Maybe today we use ATMs, we can do transfers, That's how, we think of a bank. But here you are talking about a gene bank. What do you do? Do I go give my gene and get it back whenever I want?
Well, this is in fact a repository, national repository of India's heritage of farmers' varieties and also the agricultural variations. Now, this can be stored for a very long time. We have technology now that some plants like cereals, where the moisture content can be very low, well, they can be kept even for hundreds of years.
Okay.
But if they have high protein like pulses, it will be slightly lower, 80 years or so. But if there is fat content high like oil seeds, it can be still lower. That means that you can keep them, but you will need rejuvenation of these seeds at intervals of decades. But it is safe for future generations. Also, all the material is not exactly available immediately to the breeders and researchers, because that is season bound. Here you can draw at any time you like.
Okay.
This is perfect.
So basically, suppose if I am a researcher and I want to, let's say, do a research on a particular seed which is not available in that particular season, I can come to the bank and then access it. That's a kind of one service for researchers that your bank will provide, right?
Right.
And also, you say that it will be useful for our agriculture in future. How is it going to secure our agriculture in future? What role it will play?
Well, every plant has its adaptation, just like human beings and other animals, it has a range of adaptation. If the climate changes suddenly, like it happened about 65 million years ago, when all the mammoth dinosaurs were lost. So everything which is not adapted, that will immediately go away, become extinct. Here, not only it is available for the present breeders and researchers, and also in other countries they can have it on our terms. But in future generation, we do not know what will be their choices. Not only the climate, but the taste, the requirement, the market requirements, everything may change. So here we have the original accessions conserved, that they can use it to the best of their needs and advantages.
See, when you established this gene bank, perhaps it was one of its unique kind, right? Like nobody has, I mean, very little countries have taken effort to put that kind of a gene bank. What was the scenario then when we established this gene bank in India? What was the scenario in the international level that time?
Let me begin by giving credit to Dr. R.S. Padoda, that he started these facilities, and we had imported some equipment from Canada, and 4 such modules were established then, where we had temperatures at -20, just like our Kargil and other heights. So here the seeds can be stored easily, provided they are processed. First they are dehydrated, then they are sealed in foils, aluminum foils, and then they are kept at very low temperature. Suddenly you cannot do that, because water in the cells will also freeze, ice formation, and they will die instead of. That is why in the United States there was news some time back in the 80s that these gene banks are morgues. Because unless you take good care of these seeds inside, you keep on monitoring and then rejuvenating, that part is important.
Yeah, so when we established the gene bank in India, how many gene banks were already existing in the world?
Well, I will say that there are not many, but since we did not have this facility in 1960s, 70s, we freely stored it in other gene banks, like the International Agriculture Research Centers under the CGIAR. Now, these are about 8 such gene banks where materials are stored, and our seeds that we had sent then, they are safely stored there, and we get back easily whenever we need them.
Okay, so currently, what is your estimate? How many number of seeds would be there in our seed bank in this national repository?
Well, we have now, even in this gene bank, it is one. About 4 lakhs of seed samples are there, or more than that, 4 lakhs of that. But equally important is that we have information on them.
Okay.
This is called passport data, from where they were collected, and when we collected from the farmer, what was his views, that what are his special traits, adaptations, maturity time. So this information is also with them.
So something like about 4 lakh seeds are kept in this gene bank today, which can be useful for both research today and then, for example, securing our food security in the future. That's the kind of role this gene bank would play, right?
This is one gene bank for this purpose, but there are others. like we have for fish,
Uh,
we have for horticultural plants.
mhm.
So, depending on the circumstances and situations, we are trying to create facilities, but we keep on linking them.
Linking them.
For example, this is not the best way to store to keep your biodiversity, because
when
you are
you
cutting
established-
the evolutionary development.
Okay.
So, you have to link the on-farm conservation with the gene bank. Both together then are the secure.
See, when you established this gene bank, it was one of the unique effort. What kind of challenges you faced when you established this that way back in 1990s? You know, when you started thinking about it, mid 90s, the gene bank got established. So, what were the kind of challenges that you were facing those times?
Well, the technology was not there. Then the funding was a great constraint. And when I joined NBPGR, then 2 projects were there already sanctioned with the effort of Dr. Padoda and my predecessors. Only thing was they were waiting to be implemented.
Okay.
And there were more than $30 million lying there. So, here I could make the best use. That the US Gene Bank was established in 1958.
Okay.
And they had come to revise it, and that was done in late 80s. We got that technology.
Okay.
So, we were just in a step up to date
Up to date, we can.
in the technology.
See, when you wanted to establish this in India, you took a very unique effort of not just only sending, you know, top level officials or senior scientists, but also junior technicians abroad, so that they will have the requisite expertise when we have to establish here. It is a very unique effort. So, how did you thought about such a effort?
Well, my colleagues, I found they were not that much inspired or motivated as they should be. They said that we are doing the service work, and we cannot have many publications like the basic research people. So, I talked to the chairman of the ASRB and Dr. Prasad, and then we thought that there must be some way to inspire them and motivate them, capacity building and also motivation. In this project, I had a lot of money, resources available to me. I had very good relations with the DGICAR, with the Honorable Minister of Agriculture, and in the United States also very good relations. So, we make the best use of it, and we sent about 100 scientists, more than that, to the United States just to see how they work
Okay.
and work in their laboratories. Now, when almost everyone from the NBPGR got that exposure, we included other institutes also to be sent abroad for this purpose. So, it became a matter of pride really that I am working with the genetic resources. And in this effort, we also included technicians for the first time.
This is a very interesting point, and here we will take a very short break. Keep watching Eureka. We will continue this conversation. Do you know Prime Minister Jawaharlal Nehru visited his home to take part in his marriage? Just keep watching Eureka. There are lots of interesting stories. We will take a very short break.
4 years of Modi government. The new initiatives, challenges and achievements.
मैं अपनी समस्या को अवसरों में रूपांतरित करने का आह्वान समझता हूँ।
हम जो है वो अल्पसंख्यकों के विकास को, अल्पसंख्यकों के डेवलपमेंट को देश के डेवलपमेंट से अलग करके नहीं देखते।
बंदूक और गोले की आवाज के अंदर बातचीत नहीं होती, संबंध नहीं सुना।
I do not foresee farmers' income getting doubled just by farming itself. It's time the farmer has to move towards value addition of what he grows in the farm.
Startup is essentially kick-starting of new thinking in India.
Meet the Minister, Monday to Friday at 10:30 p.m. only on Rajya Sabha Television.
Welcome back to Eureka, and we are having a very wonderful conversation with Dr. Rana, who is currently the chairman of the Agro Biodiversity group of National Biodiversity Authority, and he has had a very long experience in ensuring the security of our biodiversity in India, and he has worked on number of interesting scientific projects. Let me start with this very interesting anecdote. I was told that Prime Minister Nehru visited your marriage. I mean, that's really very interesting. And can you tell us something about it?
Well, we were surprised, and our marriage party, when we is there, and they said that the Prime Minister will be coming.
Okay.
We didn't believe first.
You mean to say that there were some hundreds of policemen and military people giving security?
Well, this is the surprising part. There was no security absolutely.
Okay.
And village didn't have electricity. So the Prime Minister came, and it was a two-storied building, and we were on the first floor, and there was no electricity, so only hand fans were there. So a perspiring Prime Minister sitting among large number of people and all ladies of the village, and he was so happy to be with that.
Yeah.
That was an interesting part, really.
Let's come back to your scientific life. We are told while writing your exam, the principal called you, and there was a person who said that when will you join? It's a very interesting anecdote. Can you tell us what exactly was happening there?
Well, it happened, I recall, in 1956. I was taking my BSc Honours Agriculture's last practical exam.
Okay.
It was entomology. And I had done dissection of frog very well, and the examiner had checked it. And then I got a chit from the head of the division, who was our principal also, Dr. E.S. Narayanan. He said, you come for a few minutes and we will give you extra time.
Okay. You should be zapped. Why he is calling me in bit of exam, right?
Exam, certainly. But he was principal. So I went there, and there was a foreigner sitting with him. And the principal said that he is Rana, among our good students, and you are free to talk to him. So he had about 15 minutes talk with me, some queries. And then he suddenly said, when can you join? And I remember having said that as soon as my practical exam is over.
Okay. And
he smiled that no occasion. I said, working with you will be my vacation.
Okay. That's interesting. That's how you landed up in your first job.
Well, I landed up a job in the USDA Agricultural Research Service. And it was nearly more than 1,000 rupees. That was something unexpected at that
time. I mean, it was a very huge amount of... right. So, you step by step went on to do a number of interesting work, and one of your work which even today people recall is when you were working with Central Soil and Salinity Research Institute, Karnal, where you found a very interesting way of finding which kind of crops or which particular crop can withstand salinity and other. Can you tell us about this particular area of research that you worked on?
Well, CSSRI, I went in 1974. The institute was founded by Dr. D.R. Bumla, a very renowned soil scientist. And largely in the beginning, it was a learning ground for me. You know, we were working with plants. But there I learned that soil water, plant roots, shoot, and atmosphere is a continuity. So what you harvest from the plant is in fact a reflection of the environment provided by the soil.
Okay.
So if there is a problem with the soil, the plant integrates it, and it is best expressed by the plant.
Okay. So what did you do? I mean, what did you do actually to find whether one variety is saline resistant or not? How did you go about doing that?
Well, we collected the farmers' seeds from salt-affected areas from Rajasthan, Kharchi Tehsil, and that is why those are called Kharchia.
Okay.
And also from Gujarat and Bhal area. It is as flat and bald as the forehead.
Okay.
So, there when we compared them, and in fact these after characterization we sent to the gene bank, they are still available.
Okay.
Now, some of them were highly resistant, but since Rajasthan is a dry place, they were susceptible to certain diseases which were there in Delhi. So, but their tolerance was unique. And those selections are still used as check varieties for comparing salt tolerance all over the world.
Okay, that's a very interesting thing. Let me come back to a different question. I mean, like I started this show by talking about this unique dolphin in Ganges. You have recently walked on a camel. Camel, to mind everybody's mind, brings in sand dunes, but this camel seems to be in water. Can you tell us something about this unique camel?
Well, you are talking about Kharai camel, and this is endemic to Kutch area of Gujarat.
Okay.
Now, it eats the mangrove leaves, which is in saline seawater, and it swims also because Kutch area is flooded a few months of the year and then it is dry.
Okay, so it is a camel which swims in water.
It swims in water, but it can also easily adapt to dry areas. Yeah, but not sand.
Okay, so what are you planning to do with this camel? I mean, you are trying to work something with this camel, right?
Now, the group of experts working with me, we are convinced that breeds of India like this, and there are many others, which are adapted to hard conditions. So, with climate change coming now, genes from these breeds will be in high demand.
Okay.
So, even in Rajasthan, what we call some areas as desert, the vegetation there has unique genes for adaptation, and they are very valuable. So, we are trying that these could be provided legal protection under the Biological Diversity Act of 2002, under its section 36(5).
Okay.
So, we are trying for that. I am hopeful that legal experts are also there in our group.
We'll talk about this Biodiversity Act, which was passed in 2002. I think we are one of the earliest countries to enact such a law. Today, roughly about 60 countries might have something related to biodiversity, acts related to biodiversity, but we are one of the earliest to do so. It's now about 15 years, right? So, what are the main motivation for making a separate law on biodiversity?
Well, you are right that we were in among the first countries who enacted such law. We had signed Convention on Biological Diversity in 1992, and then we ratified it, became a contracting party, and it is a legally binding agreement. Now, we were bound that we must respect the national obligations, although there were earlier some acts protecting the biodiversity. But the requirements in the under the CBD were entirely different. For example, it was not only conservation of biodiversity, but sustainable use of its components.
Okay.
And equally important, that sharing of benefits in a fair and equitable manner that was provided, and there was no law at that time that covers these aspects.
So, now it is about more than 15 years of this Biological Diversity Act that has come into India, and around 2003 I think the National Biodiversity Authority was established and the act was expected to be implemented. In 15 years, what do you see positive, what do you see negative?
You are right that this has been now more than 15 years. The positive things are that we have now nearly 2,000 applications we have received, and most of them we have already considered, approved, and entered into agreements for benefit sharing. That is a positive thing. Now, difficulty is that we did not have experience in implementing such legislations. So, our we went by learning from our own experience. For example, we had the agreement formats, And then we learned later that they are not to the benefit of the stakeholders
Okay.
as much as they wanted. And the agreements is to be signed on mutually agreed terms. So, it has to be agreed upon by them also.
Okay.
We changed the agreements. Then we found that even some government departments, they got approvals, but they were not entering into agreements,
Okay.
benefit sharing agreements.
Okay.
And then we sorted out, we had dialogues with the CSIR, we had dialogue with ICAR, we had dialogue with DBT, we also had dialogue with Indian Patent Office. So, we tried to sort it out and we succeeded to a large extent, but it is a continuing process. It has to be a dialogue.
Okay. So, we have moved forward, but then the distance that we need to go still exists if really we want to implement the current Biological Diversity Act. Is that what you are saying?
There are 4 major activities that are regulated under the Act, and this is under the National Biodiversity Authority.
Okay.
Now, all the foreign companies, foreign researchers, they are defined under section 3(2). Now, they have to approach to NBA, and for them it is a single window. They do not have to deal with any
Multiple
other.
agencies.
But for Indians, they have to deal with state biodiversity boards.
Okay.
So, that is the distinction. But the benefit sharing terms are the same for both,
Okay.
number one. The 4 activities that are regulated under the Act, one is that you access it for commercial utilization or for research for that purpose, for foreigners. For Indians, there is no need to have permission for access for research.
For research,
It is free.
Indians need not have any permission.
It is free, unless of course, if the material is endangered, then of course the other act will come.
Other will come.
Other act will come. So, one is this access. The second is that you cannot transfer the results of your research to foreigners without coming to NBA.
Okay.
Because research you have done, resources were yours, and you are giving them for your own contract.
Okay.
So, that way it has to be through the NBA,
NBA,
and benefit sharing terms have to be agreed upon. The
So, now coming to one major question, currently, what do you think are our major challenges in protecting our biological diversity? What kind of challenges exist?
I think biodiversity is largely now threatened by the climate change. And the temperature rise, for example, is one. Then there are now weather very strange nowadays.
Freak weather.
There are freak weathers and extremes. The frequencies are changing, durations are changing. That is one part. But more than that, there is over exploitation of our resources. Now, people do not care whether it will be available to them over the years or for future generations. Over exploitation, because population is growing, the need is growing. So, although they are justified in going for the natural bioresources, but it is then affects the biodiversity. The other part is invasive alien species.
Okay.
From other countries, when they come, they are introduced by some people, by inadvertently by us also. Now, when they become invasive, they affect our biodiversity, both plants, animals, and fish particularly. Now, then we have pollution.
Okay.
There is a land use change. Lot of forests are being diverted for development purposes. I am not questioning the need, but I am only saying that it has to be sustainable development, and sustainable development can only come with when linked with conservation of biodiversity.
Thank you, sir, being with us. I mean, we need to end the show here because of lack of time, and we have had a really wonderful conversation where we have touched upon many important areas, and one of the key element is sustainable use is what is going to lead us to sustainable development, and the need to protect use and conserve our biodiversity is a key challenge that we need to face. Thank you, sir, for being with us. I mean, it was a very wonderful opportunity.
Thank you.
Keep watching Eureka. We'll come back with another interesting conversation next week, same time.